So what I was just talking about is why we always see, the side of the moon that faces us. We actually see a little bit more than 50%, but just slightly more. Anyhow, we never see the opposite side of the moon, which is traditionally called the dark side of the moon. And so this picture shows a very good example of that. So the moon certainly is rotating about its own axis, but it's also spinning around the Earth, revolving around the Earth, and so for it to go around once about its axis, it's the same time that it takes to go completely around the Earth. And that's not a coincidence. It's what's called tidally locked. We actually see this with other moons. This in particular, some of Jupiter's moons are like this, and some of Saturn's moons as well. In the outer parts of the solar system. All right, so let's continue. All right, so Mercury is tidally locked, of course, to the sun because it's so close to the sun. But the rotation is a little bit different. Okay, so as it said, it's in what's called a 3-2 resonance. All right, and it says Mercury rotates 3 times for every 2 times that it goes around the sun. In other words, it rotates about its axis 3 times during 2 Mercury years, if you will, right? For two times around the sun. All right, so that's called a 3-2 resonance. Again, that's something we also see. There are various resonances. It's always some whole number, the number of times the object, the planet, or in the outer parts of the solar system, it's moons. How long it takes the moon to rotate about its axis, and how long it takes to go all the way around its planet. All right, so sometimes 3-2, sometimes there's 4-3, and things like that. So there are different resonances. All right, so Mercury and the moon, of course, have no atmosphere, and so here's why. If they both, as you saw earlier in the last video, they both have comparatively low escape velocities, and so let's say that there happen to be some gas molecules on the surface of either Mercury or the moon. And so what happens, of course, is because of sunlight, those molecules will pick up thermal energy, and thermal energy really has to do with speed. In fact, when you measure the temperature of something, it's really measuring the average speed. Like if you're in a particular room and it says it's 70 degrees Fahrenheit, what that is a measurement of is the average motion of the air molecules in that room. So what's happening is, of course, the sunlight would give any molecules that happen to be gravitationally attracted to either the moon or Mercury, and that thermal energy would far exceed the escape velocities, this relatively low escape velocity. All right, and of course, for less massive objects, not just planets but moons, the escape velocity is even smaller. So this is just showing you some of the knowledge that we have of thermodynamics. That has, in other words, the temperature is related to the speed. The temperature is related to the average speed of the molecules that make up a substance. That's in fact the definition of what temperature is. All right, moving on. All right, so the former Soviet Union, which of course is now the Russians. The former Soviet Union was the first to make contact with the moon. For the most part, they just crashed. Okay. So the first thing was a flyby back in 1959. This kind of stuff actually launched the space race between the United States and the Soviet Union. They actually didn't have very much luck with the moon. It turns out. They never were able to land any people on the moon or anything like that. But they were, they took pictures of the other side of the moon, in 1959. All right. So, as I said, of course, our country, the United States, is the only country to have ever visited the moon. And of course, Neil Armstrong made that very famous step in July of 1969. And then we really didn't. There were 6 missions to the moon, and the last one was in December of 1972. That was the last time humans stepped foot on the surface of the moon. And hopefully someday soon we'll go back there. There's actually plans to go back, because the moon actually has some pretty interesting minerals that we and some elements that we find on the surface of the moon. All the cratering that we see on the moon, it was caused by objects hitting the moon. When an object hits another object, the technical name for that is called a meteoroid. Rather than just a simple meteor. A meteor doesn't actually have to hit. Like if you see a shooting star at nighttime, that's just a little bit of dust that hits our atmosphere and it lights up because of heat. When objects actually hit, that's called a meteoroid. That's just the technical name for it. Anyhow. So you have to have a meteoroid to actually strike the moon and cause the surface of the moon to change. In the very early stages of the moon, as I mentioned this already, when these meteoroids crashed into the moon, there was still molten. It was still molten underneath the crust, and so that molten material, the lava, would seep out into the basins and then solidify, and would be much darker, and that's just because it was because it's what's called a basalt. I think I mentioned that earlier. All right. This is just an estimate. The craters are typically about 10 times larger than the meteoroids that created them. Sometimes the meteoroid, it depends on what it's made of. The stuff that we find on the Earth, they're generally made of iron or some metal, iron or nickel generally. But most of the stuff that hits the Earth, for example, is so not made of material that's going to make it all the way through the atmosphere. All right. About just under 4 billion years ago, there was a period called the Late Heavy Bombardment, and it was all over the solar system. This was when lots of material was still crashing into planets, into moons, and this is the material that was the original stuff that formed the solar system. And some of that material is still around. Of course, that's what the asteroids are. That's what the comets are. We'll get into that when we talk about that. So here are some different craters. Showing you that we even see craters inside of craters. Of course, there's just been so many of them. But actually, what hits the moon mostly are micro meteoroids, little tiny bits of dust, or what would seem like dust, or little, like pebbles, basically. And these things are hitting the moon all the time. It's not obvious, that's happening, but the astronauts actually experienced that when they got to the moon. The surface of the moon is kind of like talcum powder. It's called regolith, as a matter of fact, the technical name for it. Let's see. So this is just showing you, after large impacts, you can create all sorts of material. You can even create. We've even seen glass on the Earth, caused by meteoroids hitting the Earth. All right. This is the regolith I was just mentioning. So this stuff is extremely annoying, and it was to the astronauts. They talked about it quite a bit. It got everywhere. It got inside the lunar modules, and that's actually something to be very concerned about when we go back. If we hopefully we'll be going back to the moon within my lifetime and your lifetimes. This is actually a very famous. I've actually visited this crater. It's called Meteor Crater in Arizona. It's actually it's actually a little less than a mile across. It's not very deep though. Like when I got there, we ran down to the bottom of it and then ran back up. I mean, these aren't all that. The different parts of it are steeper than other parts, but it's been there. We've estimated that it's been there for at least 50,000 years. It formed about 50,000 years ago, and so there was a very large meteoroid that crashed there in the Arizona desert. It's up by Flagstaff if you ever get yourself to Arizona and you want to take a look at it. It's actually pretty cool. All right, so let's see. So what is the composition of the moon? So all the geology that took place, with the moon, it was really in its early stages. So, more than 3 billion years ago, there hasn't been any volcanic activity or anything like that ever, in modern, certainly in recent times. 3 billion years ago is a long time. So Mercury is less heavily cratered than the moon. The one thing that Mercury has that really is very different are these scarps. The scarps are also known as cliffs. They're really big, and they're also very long. There's like many hundreds of kilometers long. And up to about 3 kilometers high, as it says here, and so that there's a nice picture of one right here, and of course the Messenger spacecraft recorded these. This is actually a huge impact, Caloris Basin, on the surface of Mercury. This is not, of course, this is false color. It's not. It doesn't look like this at all to the human eye. The reason that we took this in false color is to kind of emphasize that there was this gigantic impact on Mercury many billions of years ago. But we think it was many billions of years ago. Anyhow, it was such a great impact that it actually caused what's been termed weird terrain. I don't, that's just a name that it's been given. Anyhow, on the opposite side, it hit this Caloris impact, and then on the opposite side, there's evidence of this strike. All right, I'll talk about more in the next video.